In this video, we're looking at functions. We're going to sketch the reciprocals and inverses of given functions. A quick word on notation. You can write the reciprocal in another way, but I'd keep it to this way. Here we have a trigonometric function, a quadratic function. This function isn't defined, I've just made it up. So let's start with the inverse of cosine of x. This can be written in two ways. Now for inverse functions, we always reflect in y equals x. Let's start though by looking at some coordinates. The cosine of 0 is 1, the cosine of pi over 2 is 0, and the cosine of pi is negative 1. Let's now draw our line y equals x. We now must reflect our curve, so I'm taking individual points and reflecting them in the line y equals x. Here I've rotated the paper so that the line of symmetry is vertical, and so it's much easier to draw the curve. Returning it to its original position, I now have the inverse of f. Now I'm going to look at the inverse of the quadratic function. I could do it this way. Here I'm finding the inverse function algebraically. It requires the quadratic formula, a bit of manipulation, and I get 2 plus or minus the square root of 7 minus x. But that in itself isn't particularly easy to plot, so I'm instead going to use the method before, reflection in y equals x. First, I'm going to find some key points. Here, I'm looking at intersections with the x-axis and also the intersection with the y-axis. I'll mark those points on the graph. I now draw the line y equals x. Once again, I'm going to take my graph and rotate the graph so the line of symmetry is vertical. Much easier to draw the reflection. And so this is the inverse of g, a reflection in the line y equals x. The reciprocal, though, a little bit more work. Time once again to find the intersections with the y-axis and the x-axis. I've already done this. It's the same curve as before, but I'm also going to find the minimum point. I can see that the x-coordinate must be between 1 and 3, so it will be 2, and so I find g of 2, which is negative 1. What I'm going to do now is draw the line y equals 1. This will help me with the reciprocals. First of all, I want the reciprocal of 3. That's 1/3. Then the reciprocal of 1, which is 1 itself. And next we need the reciprocal of 0. This means we have an asymptote. We can now draw the first part of the curve. Now look at the minimum of the quadratic. The y-coordinate is negative 1. The reciprocal of that is also going to be negative 1. You can also see we have 3, 0, and so that means there'll be another asymptote, and we can draw the curve between the two asymptotes with its maximum being 2, negative 1. The final part of the curve is quite easy to finish off because it must be symmetrical because we're looking at the reciprocal of a quadratic. So here the inverse and reciprocal clearly very different types of curves. Now I'm going to use Desmos to show you clearer examples of the curves. This is a quadratic. It will always have the same type of shape, but you'll notice that the reciprocal of the quadratic can change drastically due to the position of the quadratic. Now for the undefined function h of x. Here we're just going to sketch the reciprocal. Let's take individual points. Here y equals 1, so the reciprocal is 1. Then we have y equals 0.5, so the reciprocal is 2. Then once again y equals 1, the reciprocal is 1. Then y is approximately 2, so the reciprocal is a half. Y equals 1, the reciprocal is 1. And you can see that there's an asymptote which seems to be converging to y equals a third. So in our reciprocal, there'll be an asymptote converging roughly to y equals 3. And we use this information to make a sketch of the graph. Once again, not picture perfect, but it has the main features. So, to summarize, when we have an inverse, we reflect in y equals x. Reciprocal, look out for asymptotes, and also find the reciprocal of any known y values. Thank you. I hope you found that useful. Good luck.